I'm going to take you on a little adventure here. Okay. I've left some time for questions at the end, if we have time. And, oops. Yeah. So just to set the scene and let everybody know, do a quick introduction, reading off from what Alex said, definitions, because I'm going to use those words later, membrane metaphor, model for API space, and some examples that I've found that are useful. But remember, it's a model, and then questions and answers. So, hi. I'm Ahukanna. I'm a design principal. I was a technical architect, and I started life as a research chemist. And I think all of that influences the way that I look at and observe things and solve problems. I'm a computational designer, so I combine computing and design at the intersection where we have technology and people. I tend to focus on the human side of the equation, but obviously looking for where they intersect, so hardware, data, networks, software, all that stuff. And for my day job, I work as a design principal at IBM, so I'm the troublemaker or the annoying person that's going to say, is that really the best way to solve this problem for that person that we're targeting? And where I focus is infrastructure, which is the hard thing, operations, trying to prevent things from happening, and if they do happen, using analytics and deep learning to try and figure out what's happening. So, computational design is about designing for millions of people in real time, at speed, and at scale. It's not just about the beauty and the aesthetics, it's also about market relevance and meaningful results. And that's one of my favorite quotes from John Meader. So now, let's get into definitions. Everybody knows this one, but I just want to make sure that we're all aligned. So application programming interface, so it's an interface, API, is a mechanism for two or more computer programs plus a person, that bit is missing in there, to connect and communicate, transfer, transport, transform objects to create functional capability to do some work. Yeah? They're usually specified individually without any suggested sequencing and dependencies. So you can pick up an open API definition, and the first thing that you have to work out as a developer is like, okay, so which one comes first, in what order, and how am I supposed to use it? It's not actually there in the documentation, usually. Semi-permeable membrane is a biological or synthetic layer interface, again, that allows only certain molecules, think about objects, to pass through. And for me, this is counterintuitive because you think, and I'll talk about this in a minute, so osmosis is a process that uses that set of counterintuitive rules in order to allow liquids to pass through a membrane from less concentrated to more concentrated, yeah? So I have a visual. I'm a visual thinker, so I like to draw pictures. So we've got a jar, we've got some liquid. It's more concentrated on, your right, and less concentrated on the left. You can see from the concentration of the dots. So if you put a semi-permeable membrane, which basically allows a certain type of behavior into that jar, what's going to happen? Anybody? Alex? Okay, so what does that mean? What's going to happen to the levels? Let me repeat what Alex said. Alex said the less concentrated, so the bit on the left, is going to even out the bit on the right, so that they're the same concentration of water molecules. Yeah? So what do you think is going to happen? I'll put you out of your misery, I'll tell you. This happens. And every time I see this, you can do this experiment, my brain breaks because it's like, no, water's supposed to be the same level. Why is this going down and this side is going up? And it's because it's balancing out the concentration of water molecules. Not the thing that makes it concentrated is all this sugar and maybe anything else that you might put in there. It ignores that because the rule for the semi-permeable membrane is I balance water, nothing else. So looking at that, to my point, cognitive dissonance, which was the thing that was happening, is a psychological term that describes the mental conflict, which I was experiencing, that occurs when you hold two beliefs that contradict each other. I'm like, this shouldn't be happening, but it is. So I have to figure that out. So some perspectives may contradict each other, and then I'll talk about some of the models and the ways of looking at that, but it's really a spectrum. So for example, if you say something is hot, it can be hot and cold at the same time, depending on where you touch, where the temperature is concentrated, and when. If you put a candle under something and then came back 5 minutes later, it'll be cold. But it was hot just after you moved the candle. So last thing is assumption. It's a statement that is accepted as true or certain of occurring without proof. Let me just stop for a second. We use assumptions all the time when we're talking about things that we don't want to consider or we want to ignore, or a variable that we're saying we're going to assume is going to be stable with no proof, and we don't validate it and we don't check it. This, I think, I'm on a mission, and I want to recommend presumptions, which instead, you can still accept them as true or false, but you give a percentage. So you could say the presumption of osmosis never occurring with water is 100% or 0. That statement then is qualifiable and you can validate and check it. And then it allows for that probability of variation. So, last one I'm going to cover is a model. It's a thing that is used as an example to follow or imitate. However, according to George E.P. Box, one of my favorite quotes, is essentially, he said in 1976 in a paper, all models are wrong, as in they are inaccurate, but some are useful, right? And then another way of saying this, this is an author, Chinua Achebe, in 1958 said, there is no story, there is nothing that we say, even if it's fiction, that is not true. It has some element of truth in it. Back to the presumptions, you're trying to figure out what is the element of truth. Is it 0% or is it 100% in terms of reality? So a couple of examples of this modeling. We've been doing this for a very long time as human beings. And the dates, I think it's incredible. So in 1663, a partial fossilized skeleton of a woolly rhinoceros was discovered in Germany. They found this, and somebody constructed it like that. And not only did they construct it like that, 0% of this being the construction of that skeleton, which they didn't say, assumption, they called it the Maidenberg unicorn, one of the worst fossil reconstructions, model, or story in human history. So as we're building models, and I will share this model afterwards with you guys, is what's the percentage, what's the presumption of this reflecting reality, and check it, right? And a lot of times we talk about unicorns as a great thing. This one you don't want to repeat. So make sure that your unicorn is, whilst it's a mythical creature, it's not this one, okay? A century later, in 1781, a Swedish taxidermist was commissioned to stuff the remains of a lion. The story behind this and the power dynamics behind this is really interesting, because can you imagine the king summons you to the castle, right? And asks you, you wait in queue, and then you get the audience, and you're thinking, is my head about to come off? No. So are you a taxidermist? Yes. Wow, okay, maybe I'll get some work out of this, and royal commission. all right, I have this bag of bones and skin and whatever. Can you stuff it? You say no, and then you end up in the dungeons. Or you say yes, and you don't do it to his satisfaction. You end up in the dungeons. Or you say yes, and you satisfy his expectation, and you make a nice, tidy sum of money, right? So even though he had never seen one, he went ahead, used other models, like on flags and things like that, to come up with this anatomically incorrect reconstruction model story. Not as bad as the unicorn, but again. And then the last one that I think you will all be familiar with is, this is the typical project. It's a straight line. You have a starting point, you have an end, and it's a straight line. This is what people think it looks like. As a designer, this is what it looks like. It's like, what the, okay, and you're trying to work through that entropy to pull out a thread. In reality, this is what it looks like. So I think we need to start being a lot more honest, talking about presumptions and probabilities and all of that for that last story, rather than keep talking about the first one. Okay, so now, with all of those introductions, definitions, and everything, let's talk about the model that I'm proposing. And I'm hoping it's not going to be a Maidenberg unicorn, right? Things that you tend to dismiss as mistakes, you should take more seriously. They weren't what you intended, but it doesn't make them wrong. Favorite quote from Brian Eno, who is a musician and a music producer. And it could either be complexity, or maybe it's just complicated. So the way I think about solving the intersection of human problems and technology problems is almost wrapping it in 3D space in a cube. And you have different sides of those cubes that you look at and use as a perspective for looking at those problems. So, first thing, if you flatten a cube, it's a six-sided flat structure. So let's start going through the structure. So those sides I talk about are membranes. Remember the osmotic membrane I used as an example right at the beginning? If you put this membrane in between your problem space and your solutions, what moves from left to right? So definition of complicated is it consists of many interconnected parts and elements. Complicated is also past tense. That means that we know what it is in totality. There's nothing that's unknown. And the known unknowns, and this is the thing that really gets under my skin, are accounted for as what? Assumptions. Taken as fact without proof. Good luck with that. So, here's an example of Golf, classic car, thousands of known parts and components. Every single one of them goes into making that car and is essential in some way. You leave one of them out, you're not going to have that car, and there will be known issues because of it. My world consists of design systems. I've got about 350 plus-ish components that I'm using to make my Golfs, right? Planar membrane area, so this is another membrane. And from mathematics, it's flat and it extends into infinity. So if you're looking at something at a two-dimensional level, how would that relate to your problem? So for me, this is what I spend my time doing. These are the kind of planes within certain resolution that I'm defining and that eventually I'm going to give to my development team to build. But it's actually three-dimensional because there are interactions and interfaces in there and APIs behind that supply the data that is showing, or the colors, or even interactions from the user that's going to suggest whether this is going to be a dark or light interface, right? Then you have boundaries. So it's not infinite space completely, but if I then look at boundaries, then you end up with things like this. So you've got a stack where you've got your application, the piece here in the middle, the second layer, is usually where I live and where I'm designing and where we're building stuff for, but you have to understand how you plug into everything else. And then the machine learning, analytics, building semantic model, the IoT, so all of those are APIs, which we then have contracts with, and we're going to be exchanging information. And all of this is one system. This is the exploded second layer, another system, with a bunch of, every single arrow there is APIs, and interactions, and things being exchanged, and communication, okay? I can go back to this if anyone's got questions afterwards, but I just wanted to show these are real examples, things that I've worked on. So now we look at the dimensions membrane. This is the one that is fun. So a dimension, you're now looking at abstraction. So all those other things that we talked about before, now you're looking at abstraction. And those squares are the same set of squares that compose a particular relationship called area. This has the same area. If you cut these and fold them over, this has the same area. They don't look anything, they don't look anything alike visually, but they're the same, yeah? And then talking about planes and dimensions, in order to be able to define the space, remember, I talked about boundaries, I talked about the planes. You have things, this is the kind of stuff that I produce. And then I'm literally specifying you've got this many pixels to the left or to the right because that makes sense for the interface. This is an example, a card interface where you've got data that's going to be presented, there's labels, so on, in order to make sense to a human. And then finally, this line spaghetti is, again, all the interactions and interfaces and APIs between all of these planes. So next one is complexity. That means it's something that you don't know. So if you look at the definition of complexity in mathematics, which I thought was really cute, is numbers contain both a real known and an imaginary unknown part. We're using assumptions for our unknown part with no proof. How do you validate that it's actually right? And one of my favorite quotes is by Dr. Russell Ackoff, where he talks about it's better to do the right thing wrong and improve it, so you know you're going to suck right at the beginning. And then you keep iterating and improving, and eventually you head in the right direction. Remember that project with the imaginary straight line? Well, if we reflect the real one, you started at a point, you went all over the place, and you eventually got to where you needed to go, then it's better to do that than to do the right thing, the straight line. I pick point A, point B, and I'm just going to do it. And it's not really the thing you should have been doing. A crappy solution done really well is still a crappy solution. So this is where collaboration comes in. And you really need to have two parts, the analysis process, which is take the problem apart, figure out how each bit works, and then assemble. Remember that golf that I showed you? If I gave you all the pieces of a golf, could you put it together? If you didn't know what a golf looked like? I mean, you could put the tire on the roof and the other one underneath, right? The synthesis is look at the larger system. What are you trying to do? Transport people from A to B, figure out what the purpose of the containing system is, and then explain the target problem based on that subsystem. And typically what you have is two phases. Usually, a lot of times, people don't tell you what the problem was that they're trying to solve. They give you the solution. And I, the annoying designer, is going to say, whoa, hold on, wait a minute. What is the problem? We don't have to talk about that. Let's just get on and go and build the solution. No, what is the problem? Let's go back. And then you identify other things that could be similar. And eventually what happens, you eliminate, so you're checking your assumptions, and then eventually actually you identify what's the real problem, and you solve that. And this system is actually 10 times faster than just picking the problem, building it, finding out at the end, actually that wasn't the right thing to do. So picking the right thing, and then even if it's terrible the first time, but you can keep iterating and improving, is really important. This is all about the complexity membrane, okay? I told you some of this stuff is counterintuitive. And then finally, you have the interface. In our case, it's the API that we're trying to build. But it has a purpose. It's gone through all of these membranes, if you like, and then what you will end up with will be something that is the right thing to build. It addresses any complexity and uncertainty. You're very clear about the scope. You know what the dimensions are going to be. If there is one that already existed, there's no point reinventing it. And how far does it spread out? So now I'm going to go a little bit deep because this is the area that I work in. So some of you may be familiar with atomic design. It's a design system. And it's really just a way and a model of looking at user interface design. What I've done is I've added a couple of items at the front, again, inspired by chemistry, so it's called particles or elements. And if I go through an example now, let's go through a scenario. So typically, at the content layer, you're going to get some kind of data, and it will look like this, okay? So you can see that the updated time has some really long number, which I can never translate. It's epoch time, okay? That actually translates to January the 23rd, 2018. And at this point, you'll want to be able to format that for the human that's going to look at it. So you need to ask them, but you can't ask them, so what do? You ask their operating system preferences, or you ask their browser, or you ask some other proxy to figure out how to format that date. And once you've done that, you've now got a human-readable date. And this is now the view model layer, because this is what is going to be sent to the view to be exposed. So we've actually gone through 3 APIs already, or 3 membranes. One is the data collecting it. The other is the control that does the transformation and talks to their proxy. And then the last one is, okay, now I'm going to put this together to be able to display it. But when you do that, you want to be able to choose the font. Where do you get that information about the font? You get it from, again, the proxy, the user. You ask them. Where do you get the information about the background and the color and the theming? Again, you get it from the user. Do your APIs consider these kind of interactions? Iterations? Not usually. And then, once you've got all of those things, then you're going to, where I live with the design system, you usually have pre-decided a lot of these things and combinations, and then you run through it real time, this information, and finally, you combine the epoch time that was translated, the font that was selected, the background that was supplied from the user, and then any other interface affordances that you want to add in order to come up with just that text box with the background and the date. And if I decide to flip my language from English to Danish, then that's going to change as well. So it's also got to be reactive. Let's keep going. Then you start to compose and put all of these things together. And finally, you end up with multiple layers, and then these are and can be atomic and used independently, but they have a whole bunch of membranes, assumptions, decisions that you've made, which have to be reactive and flexible if your context changes, like I changed the language. So all of this changes from English to whatever I need it to be. Finally, you've got your layouts and the page layer. And all of this then comes together and is composed, having gone through all of these membranes. And that's really an example of one model that I found that's been useful, going through those 6 degrees, if you like, in order to be able to have a conversation with a system at design time and even at runtime with your user or the proxy system that will allow you to be able to make all of those decisions and then compose that user interface. So that's the membrane metaphor for API space. Yes, it was a quick run through. I'm happy to talk in detail. I even have actually some examples that I can show afterwards if you're interested. Here are the membranes, dimensions. Is it complicated? Do you know if it exists? How far does it reach in scope? What is it interrelated to? What are your unknowns, the complexity? Are you doing the right thing? And then finally, putting it together and constructing it with all the rules. So that looks like taking all of that stuff, packing it up in a nice little box, 3D, and questions.
If you have a question, raise your hand and I'll come to you so you don't have to shout through the room.
Hi, thank you for your talk. What if I'm working in a really big system? Like, is it possible for more than one cube to exist? And are there then membranes between the cubes?
Yes. Okay, let me just adjust this. I was going to say. So if you're working on more than one, you're in the boundary space. And actually, domain-driven design has a whole bunch of tools, concepts that would address that. And I showed you a couple of concrete examples of these boundaries. But for example, the second layer here, which is the, okay, I actually realized I didn't give it a name. So between the applications and then the first set of APIs, this is the subsystem, expanded with even more, but looking at everything in terms of what are the boundaries and how do you expand. And this was the thing that I was really interested in working on directly, but I needed to understand what it was a subsystem of. So yes, so that would be the boundary membrane. And after I started this, I realized that there was a whole area of practice and discipline, which is domain-driven design, talks about boundary contexts, and a whole bunch of other things that I can't remember right now that would have addressed that space.
Any other questions? Raise your hand.
Okay. So thank you.